Welcome back to ARECyber, the channel dedicated to helping you pass the certification exams that you need to move to the next level. If you're new here, be sure to hit the subscription button down below and the bell icon to make sure that you don't miss any episodes. We're carrying on through the CISSP. We are on Domain 4, Network Security and Communication. The best place to start when it comes to network security is the foundation. It all starts with one of two basic models, either the OSI model or the TCP/IP model. You might also see it as the DoD model. These are models that simply help us break down in layers how computers talk to each other across a building, across a city, or across the world. You will need to memorize these 7 layers of the OSI model. Just remember this: please do not throw sausage pizza away. So starting with layer 1, physical, layer 2, data link, layer 3, network, layer 4, transport, layer 5, session, layer 6, presentation, and layer 7, application. While the CISSP has evolved to be a more professional focused exam rather than a strictly technical focused exam, you will need to know what things, what protocols live in what layers, as well as what types of devices you might find in each of those layers. For instance, like layer 1, where you'll find hubs and repeaters, versus layer 2, where you'll find bridges and switches. Of course, layer 3, where we find routing, so routers and firewalls. Layer 3 also picks up what we call logical addressing. This is where IP lives. It's the IP of TCP/IP, where TCP lives in layer 4. You remember what layer 4 is? The transport layer. Exactly. Then moving into layer 5, where we'll find protocols such as SSL, layer 6, where we have compression and encryption, and then moving into layer 7, the application layer, where we'll find things like FTP and SMTP. So let's start at the first layer, the physical layer. We're going to talk more in depth about that layer, but that leads us up to the data link layer, where you'll find your MAC address. Your MAC address is considered the physical address of your machine. It is a 48-bit string of numbers and letters that absolutely identifies your computer from any other computer on the network. Using your MAC address, we can take advantage of things like the ARP table. The ARP table provides logical to physical addressing. You'll often hear about exploits or attacks known as ARP poisoning. It's simply an attacker trying to get the other devices on the network to believe that their machine is actually yours. So they will poison the ARP table. They will map logically your IP address to their physical address or their MAC address. You're also expected to know the difference between public and private IP addressing, as well as what class they belong to. So class A, 1 through 126. Class B, 128 to 191. And class C, 192 through 223. That will bring us to the private address space. This is probably the IP addresses that you're most familiar seeing. A Class A private address space will start with 10 dot and then whatever the total range of hosts are available on that network. A Class B will start with 172.16.x.x, x being the number of usable addresses on that network. And then Class C, 192.168.0.x, and again, X being the number of usable addresses on that particular network. Now, there are some special addresses that you should know about, such as your loopback address or the 127 address. You'll usually see it as 127.0.0.1, and that being your home address of the computer. Or you might see a 169.254 address. That is the APAPA address. What that is telling you is that that the DHCP server on the network that you are trying to attach is not operational or it's down. Next, let's talk about some different types of media, starting with coaxial. Coaxial is what you're thinking. It's a thick wire surrounding one single thick copper wire on the inside. Usually using a BNC connector, you will connect it to your cable modem. And then there's twisted pair. These are your typical Ethernet type cabling, Cat5, Cat5e, Cat6. They are simply twisted pairs of copper wire inside a plastic sheathing. The thing to remember with twisted pair is it is susceptible to EMI and crosstalk. However, fiber is not susceptible to either. Fiber uses a directed beam of light to transport your data. That brings us to routers, firewalls, and switches. Again, routers live at layer 3, the network layer. It is there simply to route traffic from one domain to another domain, whether that domain be in the same city or across the planet. Typically, one router is identified as one single broadcast domain, whereas the switch breaks up the broadcast domain from the router into multiple collision domains. The switch lives at layer 2 of the OSI model. Again, this is where your physical addressing is. On the switch, that is where you will find the VLAN or the virtual LAN. When configuring my router, I have a couple different options to choose from. Typically, I will choose between whether I will NAT or PAT my address space. NATing, or network address translation, uses private IP addressing. Those are the 10 dots and 172 dots that we just spoke about. It will map those private IP addresses to a public IP address. Whereas padding, it's very similar but a little bit different. Instead of using private IP address space, it allows all the machines or all the hosts on the network to utilize a single public address. The way your computer is differentiated from another is by attaching a specific port number to your address. So those are the basic differences between NATing, network address translation, and padding, port address translation. Next, we have firewalls. Firewalls are layer 3 devices, and they're there to act as the traffic cop. Most firewalls perform what we call stateful packet inspection. In other words, it takes note of not only the source and destination, but also the type of packet. For instance, whether it was a SYN or a SYNAC that has passed through the interface. Stateful packet inspection firewalls are an excellent protection against DDoS attacks. All firewalls should operate on the principle of implicit deny, or DAPE. DAPE simply stands for deny all, permit by exception. Unless there is a specific reason why your host needs to go to a specific address, it should be denied. That's going to do it for the beginning of Domain 4 of the CISSP exam. Next time, we're going to talk about VLANs, TCP versus UDP, different wireless standards, and the difference between a LAN, MAN, and a WAN. Again, if you enjoy these videos and you want to see more, hit that subscribe button and share it with all your friends. Each week, I take from the comments below to select the next week's videos. And now we have a Patreon page. You can go over to Patreon and become a supporter of this channel and get some nice goodies out of it as well, like early access to every video that I release and one-on-one mentoring sessions to give you that extra edge to pass the certification that you need. The address, patreon.com/ARECyber. Thanks in advance for your support. And remember, visualize success and you will succeed. I'll see you next time.